Welcome and thank you for joining. Here's another example of simplifying rational expressions. So I chose this unique sort of expression so that we can actually combine together addition, subtraction, rational expressions, and division. So let's get started. So what we have in this case is 3 minus this rational term, 2 over x squared minus 4. All of it is divided by 5 plus this rational term down here. So the first step in this case would be to rewrite the expression so that we have room to combine these two terms in the numerator and combine the two terms in the denominator into a single rational expression. So what we have in here is 3 minus 2 divided by x squared minus 4, and then all of it divided by 5 plus 7. Now, one thing that we want to remind ourselves of is that whenever, especially when we have denominators, we want to write them in the correct order, meaning that we want the highest degree term and then the lower degree terms following subsequently. So this is the only transformation that we did in this step. So instead of writing 2 minus x, we wrote negative x plus 2. So in the next step, we are going to combine these two terms. As you can see, this is a rational term, and this is a monomial. So what we're going to do is we're going to combine by making the denominators the same. Now, the denominator of the numerator, this numerator in here, has the lowest common denominator of x squared minus 4. So what that means is that we're going to give number 3 a denominator of x squared minus 4 and multiply the numerator by the same thing. And then minus, nothing will change for the moment being with this second term in here. And we do not want to expand and simplify, not yet, until we have denominators the same, because we know that we need to combine the numerators. And then the same thing with the denominator, 5 will be multiplied by negative x plus 2, both numerator and denominator, so they have the same denominators, and be ready to be added to each other. So 7 over negative x plus 2. So now that the denominators are the same, we can simplify each part of this big rational term. And I am going to highlight in red the big fraction, because as you can see, we have multiple fraction lines in here, but this is our bigger division. And we'll combine the terms in the numerator, and in this case, we're going to have 3x squared minus 12, and then minus 2. So 3x squared minus 12 minus 2. And the denominator is x squared minus 4. And down here, we'll have negative 5x, and then plus 10, plus 7, and then the denominator is negative x plus 2. So next we will take care of this division. So remember, when we divide two fractions, the division will turn into a multiplication, and the fraction that comes after the division, which would be this denominator here, will flip, which means we have negative x plus 2 in the numerator divided by negative 5x plus 17. That would be this numerator in simplified form. So now that we have brought this expression into a sort of what I would call a more familiar form, so we simply have the multiplication of two rational expressions. So we're going to start with taking care of the simplification process. So we're going to start our simplification process by factoring everything. So remember that in multiplication we factor everything. Now this numerator here, we don't have much to factor, so we're going to leave it the way it is. And the denominator is, if you can notice here, difference of squares, x squared minus 2 squared, which will factor into x minus 2 and x plus 2. And then multiplied by negative x plus 2, we're going to take out the negative coefficient because it belongs to the leading term, or the first term in the expression of the numerator, and we're going to do the same thing to this denominator. So negative will come out, and then in brackets we'll have 5x, and the positive 17 turns to a negative. Don't forget that. Now, once we have the expression completely in factored form, we are going to take care of the restrictions. Now, remember that for restrictions, this cannot equal 0 and this cannot equal 0, so the denominators. But remember that also this numerator cannot equal 0. Remember that we brought this multiplication from division, which means that if this numerator is 0, right here, then this expression would be undefined. So that's why we have to take care of 1, 2, and then this numerator when we complete the restrictions. So the restrictions in our case would be x plus 2 minus 2 different than 0. That means x has to be different than 2. X plus 2 different than 0, which means x has to be different than negative 2. And also 5x minus 17 has to be different than 0, which means that x has to be different than 17 over 5. We said that we'll take care of this as well, but since we've already stated the restriction on x minus 2, we don't have to write it twice. And next we have to simplify. So we have 3x squared minus 14 divided by x plus 2 times 5x minus 17, and that is because the x minus 2 and the x minus 2 here simplifies. The two minuses will turn into a plus. This will be our final answer. And lastly, we will have to state the restrictions at the very end in the final answer. X has to be different than 2, negative 2, and 17 over 5. And this is it. And thank you for learning with me. Bye for now.